Hello everyone, and let me introduce myself. I am Habib Rahman from University of Calicut. I am doing research in active galactic nuclei with Professor C.D. Ravikumar, University of Calicut, and collaborating with Dr. Sundar Sahayanathan from BRC. I did graduation from MMO College, Manasheri, post-graduation from NIT Calicut, both are in Kerala, India. Now I would like to share with you some results of my independent research work. I was tried to publish it in MNRAS. I submitted the manuscript to MNRAS. They considered it very well and gave some suggestions and pointed mistakes on it. It was great helpful. Thanks to MNRAs. The work is closely related to special theory of relativity, general theory of relativity, and quantum mechanics. So I tried to publish it on 18th April because the day is very important. The great theoretical physicist Albert Einstein passed away on the day. So I submitted the manuscript to archive. They sent me a mail and the scheduled date and time for the publishing. It was fixed on 17th Monday 17th April 2023. The time is 00:00:00 GMT, Greenwich time. It's about 18th, we can say like that. But unfortunately it was not happened. Then I improved the content based on their comments, and so thanks to the archive team. So let me present the work. The topics which we are going to discuss is there. Einstein is exactly correct on the Planck scale, and the question is, are the fundamental constants always constant? So this is great legend. So we will start from special theory of relativity, and we know that relativistic character of space-time structure, and that is a fundamental behavior of the nature, and the consequence of this behavior is we know this, the time dilation, length contraction. What it means? It means if we are moving faster, the length will shorter in the direction of motion, and also that motion will affect the flow of time. That is, moving faster means slowing down the clock. Okay, so and we know that there are some fundamental natural units are there, which is called the Planck scale. And what is Planck scale? The fundamental constants of general theory of relativity and fundamental constant of quantum mechanics, and we combine these constants G, gravitational constant G, and speed of light C, and the Planck's constant H. This combination gives, it arrives at a natural unit, unit of length, unit of time, unit of mass, everything is there. That unit is called Planck unit or Planck scale. So it is given that the Planck length is given in equation number 1. LP0, let us call it as LP0, that's equal to under root G0 H0 divided by C cube. That is, the value is approximately 1.61 into 10⁻³ 35 meter, and I used G0 and H0. We will come to that. The time and Planck time is defined the time needed by something moving at the speed of light to travel this Planck length is the Planck time. So it is also given there, equation number 2, and the value is approximately 5.39 into 10⁻⁴ seconds. So what we did is that we just applied the relativistic character of space-time structure to the Planck length and Planck time. So we will get the equation number 3 and equation number 4. See that equation LP, we are proposing that this Planck length is varying. It depends on the observer's velocity. Similarly, like length contraction, time dilation, we can also say that the Planck length LP is varying accordingly, according to the idea of special theory of relativity. So LP0 is the Planck length in rest frame. So LP equal to the dynamic Planck length LP equal to LP0 into root of 1 minus v square by c square. So just substituting the value of LP0, it is already we discussed, and the time Planck dynamic Planck time can be defined as the distance or the length divided by velocity. Time is just simple. Time is distance traveled divided by velocity. So just LP divided by v. That is equation number 4. So we will also get the same equation for this TP that is given in equation number 4. So what this equation imply, if we analyze this equation, it is saying that what are the quantities are changing here. See, look at the equation number 3, look at the equation number 4. We know that the postulate of special theory of relativity, that is very fundamental, that velocity of light is constant in vacuum in our space-time structure. So it will not vary. So the possible variation occur in the gravitational constant G0 and Planck's constant H0. So we are proposing that the dynamic value of the fundamental constant G and H depends on the relative velocity v of the particle or a wave in space-time structure. So it is given equation number 5, H is equal to rest frame value H0 into root of 1 minus v square by c square, and where H0 is the Planck constant in rest frame, and G equal to G0 under root 1 minus v square by c square. So G0 is approximately equal to 6.67 into 10 raised to minus 11, and its unit there meter cube kilogram inverse second raised to minus 2 is the measured gravitational constant in rest frame. So this equation number 5 and 6 giving the dynamic nature of Planck's constant and gravitational constant. So then I was trying to check the invariance of this defined dynamic Planck length and dynamic Planck time. So I did that calculation, and it's showing that the dynamic Planck length and dynamic Planck time invariant under Lorentz transformation. So this S square is the space-time interval between two frame of reference, and the invariant space-time interval will be like this. It's given in equation number 7. So I did it in one dimension. If we are doing 2D or 3D, we will get the equation accordingly. So this is the invariant space-time interval of space-time interval if we are considering dynamic Planck length and dynamic Planck time. Okay, so next we were I was looking into the I was thinking about the quantization of the space and time. So we know that the quantization means anything can be integral multiple of some fundamental unit. So according to the quantization rule, we can propose that any distance delta x and any time interval delta t passed by a particle or a wave can be represented as an integral multiple of dynamic Planck scale. So the proposal is that the any distance delta x can be written as n times, that is integral multiple of the Planck dynamic Planck length. So just multiplying n with the dynamic Planck length. So we will get equation number, substitute LP0, we will get equation 8. And similarly the time also, time can be quantized n times the dynamic Planck time. Okay, so it will give equation number 9. So where n is a integral integral numbers 1, 2, 3, etc. Okay, so we after that I was applying this idea to the present explanations of physics, that is present explanations of time dilation and length contraction. So we know that if we are moving fast, the length will contract shorter, okay, in the direction of motion, and moving faster means slowing down the clock also. So the what is really happening there in time dilation and length contraction? So it is that we know the Planck length is changing, is decreasing when we are moving with some velocity v. So in relativistic case we observed time dilation and length contraction. Actually this time dilation and length contraction is happening because of the dynamical behavior of space-time structure, that is space-time structure is contracting or the shortening. So we are proposing that actually this dilation, time dilation and length contraction might be due to the quantum mechanical behavior of space-time structure. This idea could be prove the equivalence of gravitational time dilation and velocity time dilation. Something common is happening. It might be the contraction of Planck length, dynamic behavior of Planck length in both gravitational time dilation and velocity time dilation. Accordingly the time also changing because of that variation of length, Planck length. Okay, so I applied these ideas to several contemporary issues, and let me discuss it briefly, the result which we are proposing through this idea. And this representation, that is the dynamic nature of fundamental constant or dynamic nature of Planck length and Planck time, may lead to the generalized uncertainty principle, and the definition of dynamic Planck length and dynamic Planck time itself proposes a reasonable explanation for singularity and singularity breaking during the gravitational collapse, and possibly at the time of Big Bang also. It will give the idea about why there is a singularity, how the singularity broken, like that we can say by using this proposal. And the nature of dark energy and its negative pressure could be analyzed in the background of gravitational collapse, and our investigation showing that the quantum nature of gravity could be repulsive. Okay, that might be the reason for the expansion of the universe, and this approach may change our view of gravity, existence of extra dimensional universe or parallel universe, and the problem of dark matter could be solved from such a viewpoint. And the bending of light in gravitational field could be represented as the consequence of dynamic Planck length. The work is going on, we will discuss it soon. Okay, so the conclusion is the maximum speed of light in space-time structure will be constant, that is 3 into 10 raised to 8. Sorry, it's meter per second unit, I forgot to put the unit. And the fundamental constants, second conclusion is the fundamental constants may not be constant. It can be approximate to be constant in non-relativistic case. So these are the conclusion from these studies. So thank you all, and I request everyone to share this video to the scientific community, to the students, and your teachers, professors, and great scientists, whoever in your contact list. Thank you all.